Hey everyone, welcome back. So in this video, we shall take a look at the uniform distribution. So this is a standard distribution. So like for discrete distributions, we studied some of the standard ones such as the binomial, geometric, and so on. For continuous variables as well, there are some standard ones that you need to know, and one of them is the uniform distribution. So if we have theta 1 and theta 2 are two numbers and theta 1 is strictly less than theta 2, a random variable y is said to have a continuous uniform probability distribution on the interval theta 1 and theta 2. You can also denote it this way, right? X, this should have been capital X. X follows U for uniform on the interval theta 1 comma theta 2 if the density function looks like this, right? So it's basically f of y is 1 upon theta 2 minus theta 1 and it's 0 otherwise. So you see that this density function is a constant, right? It does not depend on y. So the continuous uniform distribution represents a situation where all the outcomes are equally likely between some minimum and maximum value, right? So this theta 1 would be the minimum value and this would be the maximum value, and all of the outcomes are equally likely. So this is how, if you were to graph this distribution, this is how the graph looks like, right? So theta 1 is 1 and theta 1 is 0 and theta 1 is 1. So that's uniform 0, 1. And if the density is just a constant 1, right? And it's 0 everywhere else. So I'm just showing the part where it's non-zero in this graph, right? This is uniform with parameters 10 and 20, or on the interval 10 and 20. Again, it is just a constant. So now, given a PDF, we need to first verify that given a function f, right? The first job is to verify that it is a legitimate probability density function. So basically, you need to verify these two things: that it's non-negative, and the integral is equal to 1. Okay, so the first part is easy to see. For the second part, you just integrate. I think this is missing dy here, right? You integrate over this. This is just a constant, it comes out, and then you're left with theta 2 minus theta 1 divided by the same thing, then that's 1. So we verified that this is a PDF. Then we are going to find the cumulative distribution function of x as well, right? So if you remember, cumulative distribution function, so f at a is going to be is minus infinity to a f of t dt. This is the density, but this distribution only lives from theta 1 onwards, so theta 1 to a, and the density is theta 2 minus theta 1 dt, right? So you'll solve this integral to get the or you'll simplify this to get the CDF. This is how the CDF looks like. So see if you're able to get this on your own, right? So again, so f of a, right? F of a is probability x less than equal to a is this integral, right? Theta 1 to a. So this variable lives only between theta 1 and theta 2. So for any number less than theta 1, the CDF is going to be 0. So this is not too different from the CDFs that we were building for the discrete variables, right? So it lives between theta 1 and theta 2. So between theta 1 and theta 2, you get this. So basically, you will solve this expression or simplify it to get this form. And for a greater than 1, we know that this is going to be equal, for a greater than theta 2, because theta 2 is the maximum value it takes. So probability that x is less than equal to, so for this case, so probability x less than equal to a, if a is greater than theta 2, is just basically theta 1 to theta 2 f of t dt. So this is the entire integral, and you know that this integral is equal to 1. So that's where you get this 1 from. So again, think about the values that this random variable takes, or the range of the values is between theta 1 and theta 2. So your CDF will have these three parts to it, right? Below theta 1, between these two values, and above theta 2. So next we're going to look at the mean and the variance. We know that the expected value of x is just integral of x times the density. Again, this variable lives only, so it's uniform AB, so it lives only between A and B. So we don't need to, and it's 0 everywhere else, so we can just integrate from A to B instead. X times the PDF is this, and you simplify to get A plus B by 2. So this is fairly straightforward, right? You only need to know how to do basic integration in this step. So for variance, we know that variance is expectation of x squared minus mean whole square. We know the mean is this. So we next calculate expectation of x squared. Again, integral A to B, x squared times the density. So you get this form. So you basically get b cubed minus a cubed divided by 3 times b minus a. b cubed minus a cubed can be expanded in this form, okay? You probably studied this in school. In any case, b minus a cancels out and you're left with this. And then you can combine this expectation of x squared and this mean to obtain the variance. The variance should have this form. So make sure that you're able to obtain this exact form of the variance. So that's all for this video. I'll see you in the next one. Thank you.